Morning. Hello, everyone. As soon as I found out that my presentation was going to be one of the last, I had to refocus a bit my presentation to something a bit less technical, in order not to bore you before the finishing party. I want to start talking about health. You might all agree that health is not at all technical, but instead much more boring topic. And you might wonder, why did I choose this as my to start with? Well, the reason is exactly because it is being regarded as inherently boring, and I don't know, it's not sexy, it's not fascinating, it's not as sexy as much as Docker or Mesos. And the reason, in my opinion, is that we as engineers want to build stuff to do more and not to restrict ourselves to some limits, and also not to restrict someone else. So what's the same with health and information security? Both topics are overwhelmingly complex. And they depend on lots of factors, like, for example, health depends on whether we sleep well, whether we eat well, whether we breathe fresh air, have some exercise, have, and if, so the same is for information security. It is similarly overly complex and hugely important, but sinfully overlooked, or very often sinfully overlooked. And I'm not going to show you any scary tales or risks, graphs about risks raising threats and number of hackers over there, because it works the same to motivate you thinking about both health and security as exercising, as treats of chronic diseases motivate you exercising, or pictures of lung cancer motivate you to stop smoking. So information security is mostly, I would like to present first some basic concepts. And as I told you, in order to not bore yourself, neither yourself nor you, I've added some example for, this is a formula that I've actually made up. And as you can see here, this is a price that we pay daily for not being, for neglecting security. And the factors here is risk of being hacked yearly. The second is the cost of a breach, or even going out of business. And the only constant here is number of days per year. This actually never changes, but risks are growing constantly. We see number of hack attempts grow almost exponentially. 70% of firms admitted they tried to being hacked, and cost of a data breach also rises together with your volume of data. So you see, this is not motivating. So that's exactly the point, that these formulas and graphs, they don't do anything. That's why I brought some colors here, fancy colors, and this is a CIA triad. I'm going to speak what information security is about. It is about mostly about adhering to the following fundamental principles. And CIA in this case is not the agency. It is confidentiality, integrity, and availability. I think most of you already know, but let me just remind you what it is all about. So confidentiality is a feature of a data system which guarantees that data is not disclosed to unauthorized users, entities, or processes. And it is as simple as that, but the means by which we we achieve this feature is a range from access control systems, which can be very difficult to set up, to encryption, which guarantees that data, even if obtained, will remain secure, and also obscurity, on which I will talk a bit later. But essentially, it is not telling anyone what data do you have, where to access it, and how and when. So the next is integrity, and it is also a feature of a secure computer system, which guarantees that our data is trustworthy, our data is accurate, and it is unmodified by unauthorized users. And means by which we achieve that is by either auditing access logs or by hashing. We can hash the data and see whether it has been modified by an authorized user. I think that this is it should not be confused with hashing and error correcting on the lower layers of infrastructure, where these are used to tackle unreliability of both media and storage. So availability is also a feature or a principle which guarantees that our system is fault tolerant, is resistible to disaster, so it covers also disaster recovery and redundancy. It always inevitably increases costs, but this is the feature we, in my opinion, pay most attention to, because it is most feasible to our clients. So that's it about the basic fundamental principles. Now let me talk about best practices, and I'm in no way a certified security expert. I'm a web operations engineer, and those lessons I would like to present to you are actually hard learned from our experience in Kainos Smart to becoming SOC 2 certified. SOC 2 is a very rigorous certification process. It's a security assessment that just an attempt of it costs $100,000. So it was quite a journey for a four-person DevOps team to raise our infrastructure and all our processes to several levels up. So yeah, let's begin with obscurity. So the first as I started speaking about Kainos Smart, I would probably stop here, because I would not tell you what do we do, neither what kind of information do we have access to, what kind of information does our system have access to. And it is actually the best thing you can do if you are dealing with business clients. Leave this to your sales team. Actually, they are experts. They can leave very good first experience on what your system do and what it doesn't, without revealing unnecessary details. It is cool to brag about your security. You are secure, cool. But what do you hide? No one should care. So obscurity is by no means is a strong method, because there is no guarantee that someone wouldn't guess the port you use for secure shell for SSH or your database username. It is, but only by layering security on different security measures on top of each other, what makes it actually work. So layering by adding different layers like an onion helps us to tackle inherent risk associated with every security method, and by putting them one in front of another. And so by multiplying the risks, we can reduce the overall risk. And layering is used in authorization in access control systems by like MFA. Well, in MFA is multi-factor authentication, and in my opinion, multi-factor authentication should be used more and more. It should become a security standard, de facto standard. For example, in Kainos Smart, we use it almost everywhere, starting from our custom-built deployment solutions to Slack, to connect to VPN. Also, we've required for every user in AWS identity management system. And we've even added this layer of security to our SSH servers. So when we log into SSH, we need to put a code from a phone or OTP device. And likewise, this is a structure presented here. Not a structure. These are different layers by which you can execute a command, a privileged command on our server. So to execute this command, you need to know password for sudo. You need to enter before that. You need to enter OTP code and SSH to have an SSH key, which lies in a TrueCrypt volume to which you have access only if you are within our network. So this kind of layering is what is very efficient. The next principle is least privilege. It's probably the least convenient principle for both developers and operations, because obviously it was invented to mitigate risks of being hacked or fraud or a compromise or a human error, and essentially least privilege is giving permissions to some user or a process only the bare minimum that it needs. It is very inconvenient because there is nothing more annoying than getting permission denied for a server or action you should definitely have access to, or trying to get an approval to amend those policies, or from the other side to maintain, to write, to set up those policies. And I'm talking here, of course, about Amazon's IAM, so Identity and Access Management System, which gives us, of course, immense control, but it is sometimes startlingly difficult to configure. And there is no wonder why both IAM and all firewalls deny everything by default. But I would like you to think about this about this principle or practice a bit differently. Instead of restricting yourself, think of it like getting rid of unnecessary stuff. So, like if you don't print from your servers, delete the CAPS package. If you don't use UDP packets, block it in the firewall. And if you don't use built-in vendor error reporting service, so just disable it. Shut the unnecessary doors, reduce the attack surface. And in this way, disabling the root account and using named account everywhere whenever possible is a very good practice. So that if something bad happens, you can be sure that this user or process can't do very much damage. The last but not least, separation of duties. I know that we are on a DevOps conference here, and separation of operations and developers and operations is kind of a thing we try to fight here. But nevertheless, this principle has no logical. It is not at all in conflict with DevOps principles, because by separating roles, by dividing your responsibilities for your business processes among different people, gives no one person too much power. And like code reviews, one person writes code, the other person needs to approve it. That's basically this principle. Deployment approvals here is the same. Although we are moving away from it to automated delivery pipelines, where such approvals are kind of automatic now. These deploys are approved by integrity, integration, unit tests, system tests. So we're moving away from it. Likewise, audit of operations is also the feature that we've introduced in Smart. So now access to our production service is only operations team have access to this production, not technical architects. On the other side, they have full control on audit of our actions. We've also separated multiple factors of authentication to Amazon root account, so that neither operations engineer nor technical architect can access this root account, almighty root account, on their own. But instead, they need to sit together and only then perform. It might be contradictory to what I've told before, to disable root account, but you can disable AWS root account, and you need them it sometimes to approve penetration testings. So these are separation. These are best practices. But knowing those practices and also having a better perspective of it, and actually being convinced to look after security better is in no way sufficient to maintain those policies and to stay secure all the time. So I've came up with a simple, like a habit loop. First of all, you need to learn, of course. That's how we've started our careers. We went to university to study things, to learn something, then only to scrap this, and when we came to work to learn again, to learn to do things. Then once you've learned some new stuff, of course, communicate it, share it with your team, start this discussion, raise awareness. This way, you will find a support group. The people will agree with, which will agree with you. They will encourage you to improve and remind you, even sometimes, even if being sarcastic, they will remind you to improve. And communication about security within your team is actually very important, as human factor remains the weakest link in security, in information security overall. Probing your security is also very important, because you don't want to find out about which dangers did you have, or which vulnerabilities you had after the breach. So use all kinds of penetration tools. For example, in Smart, we use Arachne, Nessus, Amazon Trusted Advisor, Amazon Inspector. Use these tools. Find out what dangers do you have. They will pinpoint the most vulnerable points, and yeah, they will provide also an accountability. So you will see how much you have improved since the last time. So after probing all of the, and knowing about where the greatest dangers are for you, automate all of the infrastructure, all of the infrastructure code and provisioning and configuration, so that those problems won't pop up again after you provision new environment. And yeah, the best habits are actually the habits that delegated to someone else, and in this case, these habits are computers. So automate your security checks, automate your scanning through logs, looking for probably fraudulent actions, and celebrate. Of course, any habit won't be successful if you won't reinforce it through celebrations. So, fix the security issue. Celebrate! Hooray! Good for you. Better yet, team events. Maybe grab some beer. Go for a party. Yeah, this is very important to establish a habit. So that's we've covered habits. So three R's of habit formation. It's reminder, routine, and reward. Also, we've covered the importance of support group within your team, because of the human factor, and also start small. This is also one of the most important in habit formation. If you start small, so that this won't overwhelm yourself. And from security basics, I've showed you CIA triad and best practices that helped us to be a better and secure project. And the last point for this talk would be that every project have to decide for themselves how secure they want to be, because as much as with health, it's not wise to run for 5 years just to live 3 years longer. Of course, if you don't like running for the sake of it. And likewise with security, you can be very secure, but if there is not enough functionality, your customers will, of course, leave. So that's it actually. So be healthy, be secure.